Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A growing company launches a brand new application in Azure. Everything looks fine during testing, so they deploy it to production using the first virtual machine they find in the Azure portal. A few weeks later, users complain that the application is painfully slow. CPU usage is low, memory isn't full, yet performance keeps getting worse. The team spends days troubleshooting code, storage, and networking before discovering the real problem. They picked the wrong VM family. In Azure, choosing the wrong virtual machine can hurt performance, waste thousands of dollars, or both. Today, you'll learn how to choose the right Azure VM every time by understanding VM families, sizing ratios, storage limits, network bandwidth, and cost optimization. By the end of this lesson, you'll stop guessing and start designing like an Azure solutions architect. By the end of this video, you'll own 3 concrete skills. First, decode any Azure VM name, family, processor, storage support, so you can read a spec sheet in seconds. Second, match workloads to families by thinking in ratios, not guesses. And third, use tools like the pricing calculator, Azure Migrate, and Logic App's Auto-Shutdown to stop wasting money. Let's go. Let's see if you were paying attention. What was the first skill we promised? Take a moment. Let's revisit the hook. What exactly did that developer do wrong? Take a moment. Here's the rough picture. A B1's burstable VM with a low CPU baseline costs just a few dollars a month. A comparable always-on general-purpose VM can run several times that. The B series earns credits whenever usage is below baseline, then spends them during spikes. For spiky workloads, it can significantly reduce costs compared to always-on VMs. Think of the D series as your balanced workhorse. A D2S V5 gives you 2 vCPUs, virtual CPUs, and 8 GB of RAM. That's a 4 GB per vCPU ratio, along with solid disk IOPS, input-output operations per second, essentially how fast data can be read or written, and network bandwidth. It's perfect for web servers, small databases, and steady dev test workloads. When your load is predictable, the D series gives you exactly what you need without waste. Quick checkpoint. What kind of workload does the B series excel at? And how does the burst credit system actually work? Think for a second. A financial firm runs Monte Carlo simulations on a D series. Constant 100% CPU, the thing is hot to the touch. They move to an F series VM like the F2's V2, which typically provides a high CPU to memory ratio of roughly 2 GB RAM per vCPU, plus fast local SSD storage for caching, giving compute-heavy workloads a real speed boost. The ratio flips in favor of CPU, and those simulations finish in a fraction of the time. Compute-optimized VMs are built for exactly this: raw processing power. Moving from a balanced D series to a compute-optimized F series shifts the ratio. Where a D series might offer about 4 GB of RAM per vCPU, the F series gives you roughly half that. That means more raw CPU per dollar, plus a fast local SSD scratch disk that batch analytics love. For consistent CPU-hungry workloads, the F series is the smarter spend. A DBA deploys a SQL server with a 200 gig working set onto a D-series VM, but the memory to vCPU ratio is low. The server pages constantly. Latency spikes, users scream. She switches to an E-series memory-optimized VM, where each vCPU gets double or triple the RAM, and the entire working set fits comfortably. Queries that took minutes finish in seconds. No code changes. Just the right slice. When selecting an Azure virtual machine, don't start by asking, how many CPUs do I need? Instead ask, how much memory does my workload need for every virtual CPU? Here's a simple guideline. Around 1 GB per vCPU, you're looking at burstable B-series machines for light, occasional workloads. Around 2 GB per vCPU, that's compute-optimized F-series for applications where processing power matters most. Around 4 GB per vCPU, general-purpose D-series, the balanced choice for web servers, APIs, and many business applications. Around 8 GB per vCPU, memory-optimized E-series for SQL Server, analytics, and caching. More than 30 GB per vCPU, that's M-series territory for massive in-memory databases like SAP HANA. Before comparing prices, compare memory ratios. Picking the correct ratio usually has a much bigger impact on performance than simply adding more virtual CPUs. Inside the memory-optimized E-series, you've got 3 processor paths. Intel for peak single-thread on legacy enterprise apps, AMD for more cores per dollar, and ARM with Ampere Ultra chips for excellent price performance on newer workloads. Remember the naming code. No letter means Intel, A means AMD, P means ARM. That one character tells you the whole processor story. Time to lock it in. If you've got 8 gigs of RAM across 2 virtual CPUs, the ratio is 4. That's the general-purpose sweet spot. Balanced, nothing extreme. Knowing this number before you click deploy is what separates a pro from someone who's about to learn the hard way. A NoSQL cluster needs high IOPS per node for heavy writes, or the entire ingest pipeline stalls. No general-purpose VM gets there. The LSV2 series, with direct-attached NVMe SSDs, NVMe, or non-volatile memory express, is a high-performance protocol for SSDs that slashes latency, can deliver extremely high IOPS and throughput. For instance, an L8SV2 gives you a large NVMe drive. Check current specs for exact numbers, but know that if your app is disk-bound, this series treats storage as the primary resource. Look at a D2S V5. Its capped IOPS might be only a few thousand, and its network bandwidth is limited, a fraction of what bigger instances get. If your app demands high IOPS or cluster replication needs more throughput, you hit a wall even with CPU idle. The throttle kicks in, and you burn hours debugging why disk feels slow. Every VM size has hard caps on IOPS and bandwidth. They don't scale with vCPUs. Ignore them, and you'll troubleshoot a bottleneck that isn't really a bug. It's the wrong size. A bank provisions an M-series monster for its in-memory database, dozens and dozens of vCPUs, and a massive chunk of RAM. Everything looks perfect. But replication between nodes grinds to a crawl. The culprit? The network cap. For that size, the spec sheet listed a maximum bandwidth that looked fine on paper, but their workload needed far more. They wasted weeks and significant budget before someone finally checked the spec sheet. The bottleneck wasn't the CPU, wasn't the RAM. It was a bandwidth limit they never thought to look at. We'll show you exactly how to check that number before you deploy. Network bandwidth doesn't always scale with vCPUs. Some VM sizes share the same cap regardless of how many cores you pay for. Before you cluster anything, check the maximum network bandwidth for your chosen VM size, or you'll choke replication the way that bank did. Checkpoint. If your workload's bottleneck is disk, heavy writes, large datasets, the LSV2 Storage Optimized series is the tool for the job, with extremely high remote storage IOPS. A 3-person AI startup trains a medical image classifier on a CPU-only general-purpose VM. Their estimate: weeks. They swap to an N-series VM with an NVIDIA T4 GPU and tensor cores. The training finishes in hours. That's the power of Azure's GPU-accelerated VMs, built for deep learning, rendering, and scientific simulation. A general-purpose VM on a GPU workload is like bringing a bicycle to a drag race. Not every GPU is built for the same job. If you're training machine learning models, you'll typically choose compute-focused GPU families designed for large amounts of mathematical processing. If you're running AI inference, where models answer predictions thousands of times per second, a different GPU may provide better performance at a lower cost. If you're delivering virtual desktops or CAD applications, graphics-focused GPU families are designed to accelerate displays instead of neural networks. The lesson isn't to memorize every GPU model. It's to understand the workload first, then select the GPU family built for that purpose. The right accelerator can reduce processing time from days to hours while costing less than using the wrong GPU. Checkpoint. GPU sizing. Imagine rendering an animated movie. Every frame can take minutes or even hours to calculate. Now imagine trying to render hundreds of thousands of frames. Instead of one computer working for months, Azure distributes the work across hundreds of specialized virtual machines that run simultaneously. The same idea powers scientific research, engineering simulations, financial risk analysis, oil exploration, weather forecasting, and pharmaceutical research. Azure's HB and HC series are designed specifically for these workloads, combining powerful processors with ultra-low latency networking, so hundreds of virtual machines behave like one enormous supercomputer. High-performance computing isn't about buying the biggest virtual machine. It's about coordinating many powerful machines to solve one massive problem together. Say you need 256 GB of RAM for SQL Server, but you dread the per-core licensing bill. Usually, a VM with that much memory would have 32 vCPUs. An SQL Server would charge for 32 cores. Azure's constrained vCPU feature, available in certain E and M series VMs, decouples vCPU count from memory. The hardware has 32 physical cores, but the VM presents only 8 vCPUs to the OS. The VM still gets all 256 GB of RAM. The license counts 8 cores, not 32, slashing cost by 75%. Read the name E328AIDS V5. The number after the dash is the constrained vCPU count. Not sure which VM family to choose? Start here. Bursty workloads with occasional CPU spikes? Choose B series. General business applications and web servers? Choose D series. CPU-intensive analytics or batch processing? Choose F series. SQL Server, Redis, SAP, or in-memory databases? Choose E series. Massive enterprise databases with enormous memory requirements? Choose M series. High-speed storage workloads? Choose LSV2 series. Artificial intelligence, graphics rendering, or virtual desktops? Choose the appropriate N-series GPU family. You don't need to memorize every Azure VM size. Learn what each family is optimized to do, and Azure's naming system becomes much easier to understand. Checkpoint. Constrained vCPUs. The whole point is that licensing sees only the smaller visible count. Open the Azure pricing calculator, no login needed. Add a virtual machine, pick your region and OS, then select a general-purpose D-series size like D4S V5. Note the monthly cost. Now swap to a memory-optimized E-series VM with the same vCPU count. You'll often see a lower cost and significantly more RAM. Matching the family to the workload can cut your bill substantially. Azure Migrate is a free service that discovers your on-premises servers, analyzes performance history, and recommends the right Azure VM size. No guesswork. You install the appliance, it collects CPU, memory, and disk usage over time, then suggests the most cost-effective VM that matches your workload. Migrate with data, not hunches. Checkpoint. Right sizing tools. Same E8 AIDS V5. 4 different pricing strategies. Pay as you go is flexible, but it's the most expensive. Reserve it for 3 years and you'll see a massive price cut. Spot VMs can drop it even further if you can handle the risk of them being reclaimed any moment. And auto-shutdown rules tack on even more savings. Next, we'll show you how to auto-stop dev test VMs with Logic apps. Your dev environment does not need to run 24/7. With Azure Logic apps, you build a dead simple flow. A scheduled trigger fires every weekday at 8 p.m., then the next step stops your VM. No PowerShell, no manual babysitting. Running a VM only during business hours can roughly halve your compute charges. And Logic Apps handles the stop automatically, so you sleep while your costs drop. Even experienced cloud engineers make these mistakes. First, choosing a larger general-purpose VM when the workload actually needs more memory. Bigger isn't always better if the memory ratio is wrong. Second, focusing only on virtual CPUs while ignoring storage IOPS. Your processors may be waiting for disks that simply can't keep up. Third, forgetting to check network bandwidth. Large databases and clustered applications often fail to perform because network throughput becomes the hidden bottleneck, finally leaving development and testing virtual machines running 24 hours a day. Those systems often sit idle overnight and on weekends, silently increasing your Azure bill. Every Azure virtual machine should be selected by balancing compute, memory, storage, networking, and cost, not by choosing the biggest size available. Let's test your sizing instinct. An app needs 128 gigs of memory but uses almost no CPU. The team deploys a D-series VM. Big mistake. What did they ignore? Azure rolls out new VM generations regularly, each with next-generation processors. Higher instructions per clock, better efficiency. The naming pattern stays exactly the same, just the version number increments. Before you spin up anything, always open the Azure VM series selector and check the latest benchmarks for your region. Do not deploy based on last year's numbers. Let's bring everything together. Whenever you're selecting an Azure virtual machine, follow the same process. Step 1. Understand the workload. Is it CPU intensive, memory intensive, storage intensive, graphics intensive, or bursty? Step 2. Match that workload to the correct VM family instead of simply choosing more CPUs. Step 3. Verify the storage IOPS and network bandwidth limits before deployment. Step 4. Compare pricing options using Azure Pricing Calculator and Azure Migrate recommendations. Finally, automate cost optimization using reserved instances, spot virtual machines where appropriate, and scheduled shutdown for development environments. Follow this framework every time, and you'll make Azure VM decisions based on architecture instead of guesswork. You now know how to match any workload to the right Azure VM family. Check network bandwidth caps before clustering and use the pricing calculator. That wraps Part 1 of the Azure Masterclass. In Part 2, we're going deep on managed disks and storage options. Pick the right performance tier so your perfectly sized VM doesn't get I/O starved. Subscribe and hit the bell so you don't miss it. See you there. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson. Build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.